Welcome to today's lesson where we're going to discuss in two parts the renal tubular acidoses. And what I want to talk about in these two tutorials is not necessarily what you've learned in your books about how to diagnose a renal tubular acidosis, but I want to focus on two interesting points. And the first has to do with why the kidney needs ammonia to excrete acid. And then the second is to determine why certain renal tubular acidoses allow you to have a low urinary pH, in other words, allow you to have protons in the urine, and why other renal tubular acidoses don't. So in the second part, we'll talk about pH and how that is affected by certain types of renal tubular acidoses. So let's start with the first part, which is ammonia. So I'm going to draw a little glomerulus here, which you've probably seen by now in some of the other tutorials, and I'm going to draw the rest of the tubular system. And I'm going to liken or compare certain aspects of acid excretion to something very common in the real world that you're very familiar with. So we're going to talk about protons, and we're going to equate that to cold hard cash. And we're going to talk about the tubules. We're going to equate that to your wallet. So now let's discuss how I came up with these similarities. You think about your wallet. You know that your wallet has a finite amount of space, and in that space you can put a certain amount of cash, a certain amount of dollar bills, for example. At a certain number or certain point, you cannot put any more cash in your wallet. And that's what happens with the kidney. The tubular space can accommodate only a certain amount of protons, in part because of the concentration gradient and in part because of the electrical gradient. At a certain point, the kidney cannot dump any more protons into the tubules, just like you can't put any more cash in your wallet. But the kidney knows that there are going to be certain times when the body presents to it a lot more protons than it can just force into the tubules. In other words, there's going to be some times when you need to have more cash, more money in your wallet than the physical space of the wallet allows. So what would you do? How would you carry more money with you if you can't put any more cash into a wallet because the wallet has a finite amount of space? And so what you do is you get a debit card. And the debit card allows you to put a variable amount of cash into that card and therefore into your wallet. And you can choose how much cash you want to put in, but your wallet can now hold an enormous amount of money because the debit card allows that. So the kidney needs a debit card. The kidney needs something that will allow it to carry more protons if that need arises. And that's what ammonia is for. So ammonia is generated from glutamine, which is an amino acid, and it's generated at different amounts based on how much protons the body is presenting to the kidney. If the body presents a very few amount of protons, then the kidney can probably dump those protons directly into the tubular space, similar to you just taking cash and putting it in your wallet. And so there's no need for ammonia or a debit card. But in certain states where there's a lot of acid that needs to be excreted, the kidney needs that debit card so that it can dump that acid effectively, and it generates more and more ammonia. And so that's really my interpretation of why ammonia exists. It's an evolutionary advantage that the kidney has in allowing it to excrete any amount of protons that the body provides to it. And that's the first part of this lesson. Thank you very much.